In this video, I'm going to demonstrate how Desmos can be used as a tool to verify the work that you are doing by hand when doing a calculus problem. So let's get started. This particular problem is going to be an area between two curves problem. We want to find the area bounded by the curves of f of x equals 6x squared and g of x equals 2x squared plus 16. So to graph this by hand, we know that we have two parabolas. And the first parabola, 6x squared, is going to be a fairly tall and skinny parabola. Looks something like this, with its vertex at 0, 0. And then 2x squared plus 16 will have its y-intercept up here. Let's put 16 right there. And because the 2 is a smaller number than the 6, it's going to be a little bit wider and fatter. So I'm going to exaggerate it just to make it look something like this. So there are my two parabolas. Now, we want to find the area between these two parabolas, which of course is going to be all of this area down in here. That's the area bounded by those two curves. To do that, we need to find the 2 points of intersection, this point right here and this point right there. Well, we can also do that algebraically, simply by setting the two equations equal to each other. 6x squared equals 2x squared plus 16. Subtracting 2x squared to the left-hand side, we have 4x squared equals 16. Dividing both sides by 4, x squared equals 4. Taking the square root of both sides, x equals plus or minus 2. So here we would have negative 2, and here we would have positive 2. Now, Desmos can be used to verify this very easily. Let's put in these two functions. We have f of x is equal to 6x squared. Whoops. And then g of x is our second function, is equal to 2x squared plus 16. So there are our two functions. Now we can only see one of them, so I'm going to scroll out. I know that this one has a y-intercept of 16. There it is up there, 16. And so I'm interested in the points of intersection. So let's zoom in on the point of intersection, click on either one of the graphs, and go to the point of intersection. We have 224 and negative 224. So this verifies what our graphs looked like and the points of intersection. So that's the first step in doing a problem like this, is use Desmos to graph, create your own little picture over here on your paper of what the graph is going to look like. Now, sometimes you can find the points of intersection algebraically. Sometimes it's not going to be possible. So just feel free to use Desmos. The second part of the problem is when we actually get into the calculus of this. And so what we need to do now is set up our integral. And so to set up the integral, the area is going to be the integral from negative 2 to positive 2 from our bounds of integration. And we want the top curve minus the bottom curve. Well, the top curve is the 2x squared plus 16, and the bottom curve was the 6x squared. Now be careful with all the parentheses that you're using here. It would be appropriate to put each one of these curves or functions in its own parentheses, and then you are subtracting them, and then put the whole thing in brackets because you're integrating that whole thing with respect to x. So this is the basic integral. On a homework problem, on a group work problem, on an exam, this is going to be worth probably 2 points, okay? Plus 2 points to have the integration problem set up correctly. Now, we can also use Desmos to write the integration problem. Once we know how to set it up, let's put this into Desmos. So to do that, I'm simply going to write int, and then my lower bound is -2, up arrow, upper bound is +2, right arrow to get out of that. We wanted 2 parens, and then the first function was 2x squared plus the 16, end paren, minus left paren, and the second function was 6x squared, right arrow to get out of the exponent, paren, and then dx. And now notice that it gives you the actual value of this integral. It is giving you the area between these two curves bounded by -2 and 2. And let's click on this little icon to the left to have it in fractional form. All right, well, now we can go and we can integrate this and see what we get. So the next step here would be to clean up the basic integral. So to do that, we have 2x squared minus 6x squared would be a -4x squared and a 16. So I'm going to write this as 16 minus 4x squared dx. Now this is what I want to actually integrate. So when I integrate this, the area is going to be 16x minus 4/3 x cubed evaluated from -2 to +2. Now, to use Desmos at this point, I am going to use capital F of x because in calculus, capital F of x generally means the antiderivative of a function f of x. My antiderivative is the function 16x minus 4/3 x cubed. And so I'm going to put that in Desmos. And then what I want to do is I want to evaluate that using the fundamental theorem of calculus, which I will do in a moment. So let's go back to Desmos and put in capital F of x is equal to 16x minus 4/3 x cubed. That is my antiderivative. And I'm going to get rid of the graphs. I don't need those anymore. Just it's kind of cluttering things up there. All right, so that is my antiderivative. Now let's go back and evaluate the antiderivative by hand. So we're going to use the fundamental theorem of calculus now. So the fundamental theorem of calculus says that we're going to take the upper bound and put it into the antiderivative. So we're going to have 16 times 2 minus 4/3 times 2 cubed minus my antiderivative evaluated at the lower bound, 16 times -2 minus 4/3 times -2 cubed. 16 times 2 is 32. 2 cubed is 8 times 4 is minus 32 cubed. Minus -32. And then here we're going to have a plus 32 over 3. A lot of fractions. Get used to that. Now we can take 32 minus a -32 and get 64. And then we're going to have minus 64/3. Well, getting common denominators, we're going to have 192 over 3 minus 64 over 3, which is 128 over 3. Let's go back to Desmos now. In Desmos, we already know that that is the correct answer because that is what our integral told us. But let's just see how we can verify that using the fundamental theorem of calculus in Desmos. So all we have to do now, because we've written the antiderivative here, is I can write capital F paren 2, that was my upper bound, right paren, minus capital F left paren, negative 2, right paren. And changing that to fractional form, we get 128 over 3. So what we've done is we have found the answer to this problem in two different ways using Desmos. Number one, putting the actual integral in and getting an answer, but we have no way of knowing if that's correct or not. Then we actually go through and do the integration by hand, find the antiderivative, put the antiderivative in Desmos, and then using the fundamental theorem of calculus, we evaluate that antiderivative and we get the same answer. So I'm pretty confident that we went through and did this correctly. So the moral of the story here is you should be able to do one of these problems completely by hand. You should be able to draw a sketch of the graph, figure out which curve is on top, what is the bottom, determine the bounds of integration, set up your basic integral, integrate it, which means find the antiderivative, and then evaluate the antiderivative using the fundamental theorem of calculus to come up with your final answer. Then use Desmos to verify all of that work. Anyway, that's it for this video. I hope it was somewhat helpful.